Okay, when we're looking at vertical asymptotes, right? Remember, the things that make us have vertical asymptotes are in the denominator, right? We set the denominator equal to 0 after we factored, okay? At our vertical asymptotes, we have one of three things that happen, right? If I have a graph, I could either go up to infinity on both sides, right? And my limit as I would approach that vertical asymptote, which in this case is at 0, my limit would be what? Positive infinity, right? Now, if I had them going down this way, as I approach that vertical asymptote, I'm going towards negative infinity. And then this could be one of two ways. It could be like this or in the opposite quadrants. But if I have something like this, approaching that vertical asymptote, I have does not exist, right? Because the left and right do not equal each other, okay? So I've got three things that happen. This was on our notes from last class. It's on the 3rd page, okay? So down on the bottom here, we talked about kind of making a table of values to help us figure out what our limit is going to be as we are approaching our vertical asymptote, okay? Well, we know it's going to be one of three answers. It's going to be positive infinity, negative infinity, or does not exist, right? So there is an easier way to do this. I wanted to do the table of values so you guys, you always got to get shown the harder way first, right? You're going to get some tricks here as we move on. But if I look at letter B here, okay, if I zoom in, maybe if I can. Okay, if I'm looking at this value of 1 over x minus 1, and I'm looking at the right, okay, that means I'm plugging in a point that is on the right-hand side, so like maybe 1.001. If I plug in 1.001, I'm going to have 1 divided by a really small decimal, right, which is what we did on our table, but we know that it's either going to positive, negative infinity, or does not exist. So as I'm going from the right, 1 divided by a really small number is going to give me what? Positive infinity. If this was a negative, it would give me negative infinity, okay? So we don't necessarily have to show a table of values to get our answer, okay? Okay, let's look at another one. Let's look at the next page here. Letter B. I don't even think we did this one. Did we do this one last class? I don't think so. Perfect. Okay, so we're looking at the limit as it approaches 1. Not from the left or the right, but as it approaches 1. So can I just do one of those two things? If I want to find the limit at 1? No, I have to do both sides, right? So I need to find two things. The limit as x approaches 1 from the left of our function, x minus 3 divided by, I'm going to factor that bottom real quick. It'd be x minus 1 squared, right? Or x minus 1. Okay. And I need to pick from the right as well. Okay, so when I am plugging these values in, all I'm really looking at are the signs, because I know as I approach a vertical asymptote, as I approach a number here that makes my denominator equal 0, it's going to do one of three things: positive infinity, negative infinity, or does not exist. So when I plug in a point to the left of 1, what should I plug in? 0.09, okay? I'm going to plug in 0.99. We are not going to need to use a calculator. Okay, because all I care about are the signs. Okay, so 0.99 minus 1 squared. Now if I look at the numerator, 0.99 minus 3, positive or negative? Negative. 0.99 minus 1, quantity squared, positive. Okay, if I have a negative divided by a positive, I'm going to end up with a negative. So this is going to be approaching negative infinity from the left. Okay. If I plug in a number to the right of 1, 1.01. So 1.01 minus 3 on the top, 1.01 minus 1 on the bottom squared. What do I end up getting on the top? Positive or negative? I get a negative, and then in the bottom, I also get a positive. So I end up with negative infinity. Okay, so they're both going down to negative infinity as I'm approaching 1. So my limit as I approach 1 is negative infinity. If it did not exist, or sorry, if it was positive on one side and negative on the other, then it would not exist, right? On your graphing calculator, go ahead and graph this function here. Okay, and see what it is doing at 1. Is it approaching negative infinity? Yes or no? Check yourself, okay? But this is also something that you should be able to do without a calculator, okay? But let's look at a graph and make sense of it. So as you look at that graph, right, you get something that looks like, that was kind of a terrible drawing, but you have that vertical asymptote here at 1, so it is approaching negative infinity, okay? All right, I think the graphs for the most part were pretty straightforward for everyone. If I approach negative infinity versus infinity, where are they going, okay? And then the trickier one here is example 4, remember? As I'm approaching negative infinity to the left, I can cross a horizontal asymptote, but if we can see that there is a pattern and it's getting smaller and smaller, or kind of like converging to that point, we can say that the limit exists at negative infinity at that horizontal asymptote of 1, okay? Same thing on the right there. It's going to get smaller and smaller, so we can say that it approaches 0. Okay. And then this one, I just want to double check. This one is going to infinity. Do we write infinity or do we write does not exist? We wrote infinity. Okay, good. Just making sure. Okay. However, the one on the left, does that exist? No. Okay, because it's going in between the same 2 points as I go to negative infinity, so it's never going to converge to 1 point. But as I go to positive infinity, all of these values are getting smaller and smaller, but they're going closer and closer and closer to infinity, forever and ever and ever, okay? Cool. Alrighty. So we are new stuff now, yes? Now we're looking as we approach positive and negative infinity, what is happening to our numbers, okay? So I'm gonna write something over here on the side. I want you guys to write it down with me as well. If I have a fixed number, like 1, 2, 3, 4, any number, and I divide that by infinity. Okay, if I take any number and divide it by infinity, it's getting closer and closer and closer to what value? 0. Okay, if I take the limit as it approaches 1 over x, for example, right, it is going to approach 0. So the limit equals 0. Okay, that's kind of what this, I don't know why it did this thing where it's like super out of line there, but that's what that's saying there, is if I have 1 over a really, really big number, as I take the limit as it approaches that, it's going towards 0, okay? And then remember, if you have like a number divided by 0, okay, that's because if you took the limit, like let's say, if we looked at the limit as x approaches 4 of like x plus 3 over x minus 4, right? If I plug in 4 here, I get 4 plus 3, right, which is 7, divided by 0. So when I have a number over 0, there is a vertical asymptote, right? So I'm either going to positive or negative infinity, correct? Okay. Now, I can't show you an example of every single type of problem you're going to see on your homework, okay? My hint to you is to factor problems if you can, so that it's easier when you're plugging in values to see what's happening with your signs, okay, for numbers at vertical asymptotes. When we're looking at infinity, if I go forever and ever and ever to positive or negative infinity, a lot of the times it's going to be approaching a horizontal asymptote. Okay, so do we remember our horizontal asymptote rules from Algebra 2 and Pre-Calc? Yeah, maybe a little bit. When we go over it, I'm sure it'll come back to you guys. So those are going to come back into play here when we're talking about limits, okay? So if I look at example 6 here, I want to evaluate this limit as it approaches infinity of this function of 5 minus 2 over x squared. Okay, now I'm going to rewrite this as the limit as x approaches infinity of 5 minus the limit as x approaches infinity of 2 over x squared. I can do that based on our limit properties that we talked about quite a few classes ago. I can separate them, right? Minus, addition, subtraction. I said that already. Multiplication, division, right? We can separate those limits out. So if I look on the left side, as I approach infinity of 5, what am I going to get? 5, right? It's going to give me 5 here. But then as I approach infinity, 2, don't shut up, but think about it. 2 over a really, really big number squared. 2 divided by a really, really big number is going to approach 0, right? So this is approaching 0. So 5 minus 0 is 5. So my limit as x approaches this function at infinity would be 5. Okay. Let's look at example 7. Example 7 here, I've got limit as x approaches infinity of 2x minus 1 over x plus 1. Okay. This is where your horizontal asymptotes come into play. Let's go ahead and quick graph this on your graphing calculator. Graph 2x minus 1 over x plus 1 and see if you can't tell where your horizontal asymptote is on your graph. It is approaching 2 if you look at a graph, right? So if you remember, when we talk about horizontal asymptotes, what do we look at? The degree, right? We look at the 2x over x. That's what I care about. When we're talking about infinity, this plus 1 down here and this minus 1, are they really going to affect anything? No, okay? So we're looking at 2x over x. Now, if they have the same degree, what am I going to do to find my limit? Or where is the horizontal asymptote going to be if I have the same degree? The first number, the leading coefficient, right? So my horizontal asymptote here is at 2, right? So as I'm approaching infinity, I'm getting closer and closer to positive 2. Okay, so the limit here is at 2. There's a bigger, more mathy explanation as to why that exists, and if you want to know, you can come talk to me at a later time, and I will show you, okay? Otherwise, if I show you, I think you're going to get confused, okay? So as long as you know that when you have the same degrees, right, neither one is more dominant than the other. They're the same, except for the top one has a 2, right? So we're going to take that 2 over the 1 to get us that 2 as we approach infinity, okay? All right, look at example 8. We've got 3 different examples here, 3 different exponents that we're looking at, okay? Let's start with letter B quick since it's very similar to example 7. If I look at this function, the limit as x approaches infinity of this, I have the same degrees in the numerator and the denominator, right? If I have the same degree in the numerator and the denominator, I'm looking at my leading coefficients. My leading coefficients are 2 over 3. So I'm approaching 2 over 3. Okay, graph this one really quick and see if it shows on your graphing calculator a horizontal asymptote at 2/3. Okie dokes. Moving on back to letter A. Okay? Letter A, if I look at x approaches infinity of x, 2x plus 5 over 3x squared plus 1. If my degree on the numerator is smaller than the degree in the denominator, what happens for my horizontal asymptote?
0.
It's 0. If it's smaller in the numerator than it is in the denominator, your horizontal asymptote is at 0. Okay, so this just approaches 0. Okay. And if you plug that in your calculator, it should also show you it is approaching 0 on both sides. Okay, or at infinity, sorry. Letter C, the numerator is larger than the denominator. So you would divide, right? Which we're not actually going to do here because that doesn't matter in what we're looking at. We're looking at what is the limit as it approaches infinity. Which, if we divide, we're going to get some sort of oblique asymptote, right? Okay? So we know there's no horizontal asymptote, but there's some maybe sort of oblique asymptote. But that oblique asymptote is going probably, right, to infinity. Correct? So as I approach infinity, we're looking at the signs of these things. If they're both positive here, right? If I think about plugging in infinity, 2 times infinity to the third power divided by infinity, right? 3 times infinity squared is going to be approaching positive infinity. There's more on the top. It's more dominant on the top. So it is going to positive infinity in this case. So positive infinity. Okay. Questions on those? Make sense? Again, approaching positive and negative infinity is looking at horizontal asymptotes. Okay. All right. So on the next page here, in the purple box, we're going to go ahead and explain what we just did with less than, greater than, or equal to. Okay. On our degrees. So I'm going to go ahead and write a little example of each of these next to, so that you have them when you go back and look at it. This is basically the same thing as horizontal asymptote rules, but in terms of limits. Okay. So if the degree of the numerator is less than the degree of the denominator, the limit is going to be 0. Okay, so if I wrote an example here, it'd be like the limit as x approaches infinity, or positive or negative infinity of something like x to the third over x to the fourth. That would give me 0. If it is equal to, if I have the limit as x approaches infinity or negative infinity of 5x squared over 7x squared, since my degrees are the same, neither one is more dominant, so I'm going to take the coefficients of 5 over 7. So this would be your ratio of coefficients. And probably should say leading coefficients, yeah? Because if there's more than one x term, you're looking at the highest degree. And then number 3 is if the degree of the numerator is greater than the degree of the denominator. So if I have something like as x approaches infinity of greater, so like x to the 5th divided by x to the 2nd, right? That is approaching, depending, positive or negative infinity, okay? Make sense? Okay. Now let's look at example 9 here. So example 9, we've got square roots going on. Okay, so I've got 3x minus 2 over the square root of 2x squared plus 1. If I take the square root of a number, and I'm not solving an equation, what is my answer always going to be? If I said square root of 4, you would tell me 2. Not negative 2, just 2, right? You're only going to tell me negative 2 if it's equal to, right? Okay? So every single answer, when I take the square root of it, it's going to give me a positive number. How would I show that? How would I denote that?
Don't write a negative sign.
Don't write a negative sign or absolute value, right? So I'm going to rewrite this as the limit as x approaches infinity, because again, this minus 2 and this plus 1 really aren't going to do anything when we're approaching infinity. If I subtract 2 or add 1 to something, it means nothing in terms of an infinity, right? I'm looking at what is the end behavior though. So of 3x over, and I'm going to rewrite the denominator as the square root of 2 and the square root of x squared for a second. Okay, that square root of x squared is always going to be positive, right? So really, I want to rewrite this as the limit as x approaches infinity of 3x divided by the square root of 2 times the absolute value of x. Okay, because that lets us think, well, if I plug in a negative infinity down in the denominator, right, it's going to end up being positive. Okay. Okay, so now I've got to evaluate this. I've got the degree on the top and the degree on the bottom are the same, right? Whereas before, technically this is a 2, but we took the square root of that, right? So it's actually a degree of 1 in the bottom and a degree of 1 in the numerator, right? So if I have the same degree in the numerator and the denominator, we're looking at the coefficients, right? So I would rewrite this And the reason that this works is I'll show you. I'll write it like this. Limit as x approaches infinity of 3 over the square root of 2 times the limit as x approaches infinity of x over the square, or not square root of x, but absolute value of x, right? This x over x, since we're going to infinity, infinity over infinity is not infinity, but 1, right? This is going to 1. But if I take the limit as x approaches infinity of this, 3 over square root of 2, I get 3 over the square root of 2, right? So my answer here is 3 over the square root of 2. And you do not need to rationalize the denominator. They've taught you all the way up until now to rationalize the denominator, okay? But the reason that we learn to multiply or to rationalize denominators is more in terms of those problems that we did at the beginning a few weeks ago. When you have something like in the denominator like the square root of 2 plus 1, right? We want to be able to rationalize it so that way we can solve when we're doing limits. But it does not matter now. We do not need to rationalize, okay? So 3 over the square root of 2. That's our answer. Now the b is very similar, except b approaches what? Negative infinity. So it's the exact same thing, except for, in this case right here, where am I at? Right here. Okay, if I plug in negative infinity, okay, so I'm going to rewrite this here as the limit as x approaches negative infinity of 3 over the square root of 2 times the limit as x approaches negative infinity of x over absolute value of x. And the only difference here is when I plug in infinity to my second term here, right? Negative infinity. This would be negative infinity on top. And then on the bottom, the absolute value of negative infinity is positive infinity, right? So this would equal -1. So this is -1 times, this one would still be 3 over the square root of 2. So your answer in this case would be -3 over the square root of 2. Okay. All right, we're just going to look at 2 examples in this exponential stuff. It's not as important to understand, but it is kind of good to think about. So let's look at letter A and C. Okay, letter A and C. So if I look at approaching infinity here, if I plug in infinity here, I'm going to have 2 to a really, really big number still, right? Because -3 isn't going to really affect it. And then if I add 4, adding 4 doesn't really affect anything. What is this going to go to? Positive infinity. Okay. Oh, I lied. I don't want to do C. Let's do D. No, I lied. Let's do B. Sorry. I can't make up my mind. Let's do B. Okay. Letter B is approaching negative infinity. Okay. So negative infinity would be positive plus 1. So I'm taking a fraction, -1/4, right? But the negative is not included in my parentheses, correct? And I'm taking this whole thing to a really, really big number. If I take a fraction to a really, really big number, what am I going to approach? 0. Okay? This would go towards 0. If you don't believe me, plug a bunch of numbers in. But then we're adding 5. So our answer here would be 5. This is a case of when adding and subtracting does matter, right? But before we were talking, we had fractions, and that doesn't really affect it when we're talking about horizontal and vertical asymptotes, okay? Cool. All right. We're not going to do the other 2. You can if you want. But your homework, again, I can't do an example of every single type. So the answer key, there was a mistake. I fixed it. So if you see any others, let me know. But use your answer key to check to make sure you are doing things correctly. Do not just use it to copy down, right? That's not going to help you. Make sure you're using it to help you check your answers, okay?